We are here to present our paper on relationship modeling for road geometric digital twins using spatial analysis and LLMs. The first author, Davletshina, myself, Varun Kumar Reja, and Professor Ioannis Brilakis are the authors. And we are from Department of Engineering, University of Cambridge, particularly from the Construction Information and Technology Lab. So digital twins, as you know, are digital replica of physical assets which are interconnected with both the directions. Particularly, a geometric digital twin takes care of geometrical properties of the object and their relationships. So right now here we are looking how we can model relationships in a digital twin framework. Right now, manual relationship modeling is currently a bottleneck. The current tools like Autodesk InfraWorks requires manual fitting and are very slow and labor intensive. This limits scalability for large scale road digitalization. Relationships are foundational to digital twins. Okay. Okay. So relationships, as we know, are foundational to digital twins. They enable interaction mapping and also are very essential for semantic understanding of geometrical digital twins. So geometrical digital twins can drive industry impact. They have use cases in safety assessment, predictive maintenance, simulations, and can boost productivity in transportation and construction sectors. Therefore, there is a dire need to bring automation of how we can model these relationships for digital twin creation, as well as broader adaptation of geometric digital twins. Some conceptual background. So in the theory of scene understanding, there are two parts. One is objects, and second is their relationships. How do they interact, or what is the relationships with each other? These are represented using scene graphs. The nodes are the objects, and the edges are the spatial or the functional relationships. This enables us to model digital twin in a very structured way, and use in applications like traffic analysis, asset management, and automation. So on the left-hand side, you can see there is a small graph-based structure of the highway assets and its sub-assets. And on the bottom, you can see there are relationships. So for example, car is traveling on the road surface. Street lights are installed along the edge of the road surface. So these are the kind of relationship we look to model. LLMs have been used for many applications lately, and particularly here we reviewed them for spatial modeling. So LLMs have a power to reason over spatial data using natural language prompts. They can enable relationship extraction, proximity analysis, and root queries. Particularly, they have not been tested for geometric digital twins relationship modeling. And recently, we have seen some of the applications in integrating GIS tools, which enhances their practical applications. So with this, our research objective is to kind of develop a method to model relationship between road assets using spatial analysis and LLMs. And particularly, we are looking to answer these three questions. How can relationship between road assets be modeled? Can LLMs effectively support modeling for road environments? And do LLM-based insights complement spatial analysis? With this, I will pass on the stage to Diana, who will present the remaining of the presentation.
Thank you. Hello, everyone. And let's move on to the next part. And addressing our research questions and objectives, we would like to propose a hybrid approach. It combines precision of spatial analysis and also the flexibility of LLMs. It starts with 3D objects of road environments, and also it can be labeled point cloud of road environment. And in the first pipeline, we do a straightforward thing. We calculate distances between objects, analyze spatial co-location of objects between each other to derive topological relationships. And in the second pipeline, we first generate basic geometric descriptions and concatenate them automatically into prompts for ChatGPT or any other general purpose LLM. As a result, we get spatial and functional relationships from it, and we integrate all of them into existing geometric digital twin. So if we look more in detail into the research methodology, in the first part, we, for example, calculate center-to-center distances between objects to get association relationships, and also closest point distances to get closest to relationships, for example. In the second part, with LLM-based pipeline, we first create bounding boxes around each object and get 8 bounding box coordinates for each object, and then we attach it to our prompt, and there we also ask to analyze these rows seen with these objects and find the main spatial and functional relationships. Then also to draw a graph diagram with them. In our experiments, we use CAM-Highways dataset, which is a public dataset that was also published recently by our group this year. And for geometric digital twin, we use our previous work where we segmented the point clouds and also created geometric digital twins from them. So moving on to the results, here you can see some of the intermediate results with point clusters. And here with red lines, you can see closest to relationships. Yeah, on the left, for example. And and green lines are our association relationships with that current row segment. So as a result, this all gets integrated into the final geometric digital twin, which is in the form of 3D meshed and labeled objects. This geometric digital twin was created by us in our previous work. And now, with these relationships, it becomes more holistic, and instead of just randomly floating objects, we have all of them connected with each other. Moreover, from LLMs, we also get automatically scene graphs. Here you can see a spatial relationships graph, and our observations are as follows. For the latest models of ChatGPT, it all corresponded to spatial analysis we done with distances, and it also didn't ignore any objects we fed from each 200-meter samples. And similar plot, there is a similar plot for functional relationships. Let me zoom in a little bit. So it correctly identified for all road furniture objects their main purposes. For example, barriers would border or protect the road segment. Traffic signs provide warning information, and lamps illuminating the road. And just to note, this was all automatic, so ChatGPT produced a code so that we can visualize it. So it is unredacted output. However, like in our work, there are some limitations, and the biggest limitation is the absence of ground truth dataset for relationships between road objects. So it restricted our evaluation. Also, it restricted our proposed solution, as we couldn't apply some, for example, deep learning-based approaches to train them. And another thing is that we lack condition data, for example, or any other information that would further enrich the relationships, and broader categorization could be better. So finally, still, like, even though we have basic relationships, we are fundamental and support geometric digital twins in a great way, and the fact that it is all automatic reduces a lot of manual work involved around digital twins. And finally, I would like to thank our funders, and on that note, I would like to conclude. Thank you so much for your attention, and I would like to invite you to connect with us on LinkedIn with these QR codes if you manage to scan while it blinks. So yeah, if you have any questions, we welcome them. Thank you so much.